Hello students of class 10. So today I am going to discuss the next topic of the chapter area related to circles, and the topic is areas of combination of plane figures. So in the last lecture we have discussed that how to find the area of objects separately, that means individually, how we can find the area of any part of a circle, or you can say the length of the arc of a circle. So now in this video lecture I am going to discuss the area of combination of plane figures. That means if two or more objects are combined, two or more plane figures are combined, then how we can find the area of that combined object. Okay, for example, you can say the design in a bed sheet, or design in the curtains, or design in the tablecloth. So in some designs you will find that there are combination of plane figures. So if we know the area, how to find the area of one object or one plane figure separately, then if they are combined, we have to see that which part is involved in the area. So by that way we can find the area of combination of plane figures. So already we know the formulas of sector, how to find the area of sector, area of circle, length of arc. So using those formula only, we will find the area of combination of plane figures. So according to the revised syllabus, we have to find the area of plane figures which include simple, quadrilateral and triangles. Okay, so let us start by doing the questions of exercise. You can see in question number 1 of exercise 12.3, here a circle is given and the center of the circle is O. QR is the diameter of the circle, and you can see here RQ, that is the diameter of the circle. It extends a point P to the semicircular region of this circle. Okay, this is the semicircular region, and here RQ extends a point P to the semicircular part of this circle. So now here we have to find the area of the shaded region. So what is the given condition? PQ is equal to 24 centimeter. PQ is the length of this side. This is 24 centimeter, and PR is this one, this side. This side is 7 centimeter. So we have to find the area of the shaded region. So how will we find the area of shaded region? You can see here the shaded part is not an exact plane figure. Okay, we know circle, we know triangle, we know quadrilateral or many types of quadrilateral, but this shaded region has not particular size or shape. So how we can find the area of shaded region? You can see here a semicircular part is there. This is a semicircular region, and one triangle is present, QRP. So if we find the area of the semicircular part first, if we find the area of this triangle QRP, and after finding the area, if we subtract the area of triangle from the area of semicircular region, then we can easily find the area of the shaded region. Okay, so semicircular region we can easily find the area, but here we have to see how to find the area of the triangle. So you can see two sides of this triangle is given, only QR is not given. So you can see here QR is a straight line, so that means the center angle is 180 degree. So we have learned one theorem from class 9, that angle subtended by a chord at the center is double the angle subtended by it at any point on the circle. So by using that theorem only, we can come to know that this is 90 degree, and if it is 90 degree, then this triangle is a right angle triangle at P. Okay, so using the formula of area of triangle is equal to half into base into height, because PQ will be the base and height will be RP. If we apply that formula, then we can easily find the area of the triangle. So students, see, in right triangle RPQ we can apply Pythagoras theorem. So this is by Pythagoras theorem we can write. So by using Pythagoras theorem we can write RQ square is equal to RP square plus PQ square. So after putting the values, we will get the value of RQ to be 25 centimeters. So RQ is what? RQ is the diameter of the circle. So for finding the radius of the circle, we have to divide it by 2. So that will be the radius of the circle. So 25 by 2 will be the radius of the circle. Now we have to find the area of the semicircular part. So this one semicircle will be half of pi r square. So pi we can put 22 by 7 and radius already we get 25 by 2. So after simplifying we will get the area of the semicircular part. Next come to the area of the triangular region, that means this one. So area of triangle RPQ will be half into base into height. So base is PQ, height is RP. So that will be half into 24 into 7. So after simplifying we are getting 84 centimeters square. Now see, this is the semicircular part and this is the triangular part. Okay, so now we are subtracting this triangular area, okay, from what? Semicircular area. So if we subtract this part, if we remove this part from this semicircle, we will get this area. So this area is what? This area is the shaded region area. So after simplifying this, finally you have to write area of shaded region. And please try to do the remaining part. This is simple. You have to subtract and you have to find the value and write in centimeters square. So student, next question is question number 2. Here two concentric circles are given. You know what is the meaning of concentric circles? Concentric circles are the circle having common center or same center. So there are two circles you can see here and the center is common, that is O. Okay. So now we have to find the area of the shaded part. So you can see the shaded part is coming inside the sector region. So this is the sector part of a circle. Okay. So now we have to find this area, this shaded area. So if we find the area of the bigger sector, this one, and then this is also a sector. You can see here, this is the smaller sector. Okay. So from the bigger sector area, if we subtract the smaller sector area, then we will get the area of the shaded part. Okay. So now you can see here in this particular question, the center angle is 40 degree. So according to the revised syllabus, you know that you have to do the questions on the basis of center angle 60 degree and 90 degree. So if 60 degree is given, then also you have to apply the same rule only, because we are finding the area of the shaded region. So first of all you have to find the area of the bigger sector and then you have to find the area of the smaller sector. Okay, so let us do it. You can see here, area of bigger sector will be theta by 360 into pi r square. Pi we can put 22 by 7 and radius of the bigger circle is 14 centimeters. So we are applying here 14. Okay, 14 square. So after that I am finding area of smaller sector. So the radius of the smaller circle is 7 centimeter. Okay, so now we have to find the area of shaded part. That will be, you have to find the difference of the two areas. So now see, you can see here, there are some common numbers are there. So just take the common part outside the bracket. So 40 by 360 is common and then 22 by 7 is common in both the terms. So after taking out the common terms inside the bracket, we have 14 square minus 7 square. Okay, so this part you have to simplify. Then after that you can see inside the bracket is 14 square minus 7 square. So there you can apply the formula of a square minus b square. That will be a plus b into a minus b. So no need to do square. You can just apply the identity. So that will be 14 plus 7 into 14 minus 7. That means finally you will get 21. That will be 14 plus 7. And then 14 minus 7 will be 7. So after that you can easily simplify this expression. Okay, so student, try to do the question. So student, that's it for today. So some questions I will discuss in the PDF file. So practice it and practice the example question also. Okay, so thank you for today.